All right, so this is our second video for scale. We're actually going to talk about proportions today. So this is very similar and related to the stuff we did last class with scale. It's a little bit more complicated, but once you figure out the system, it requires a lot less thought, and you can just put the numbers in and solve it. So that being said, I want to show you how to actually solve these math questions before you actually have to create them on your own. So when I talk about proportions, it's always going to be a fraction equal to another fraction. There's also always going to be a variable, whether it's x, y, whatever letter, but that's what you're trying to figure out. Now what you hopefully notice is that this is basically exactly the same as what we did last unit. We have to figure out how to get x all by itself. So what we're going to do is this first example. I know I want to get rid of this divide by 10, so I have to do the opposite, which is multiply by 10. And on this side, I also have to multiply by 10. So now you can just put this in your calculator if you want, 2 divided by 5 times 10, or you could write it this way. That's fine too. But now these two cancel out and x is by itself. So when you do the actual work, this becomes 20 divided by 5 is going to give you 4. So now we know that this missing number was 4. This question over here is a little bit trickier. The reason it's trickier is because the x is on the bottom. When the x is on the bottom, we can't divide or multiply to get rid of this 2. So what we're going to do is we're actually going to kind of cheat, and we're going to flip it. So what we're going to do is we basically take the entire fraction, and we're going to flip it upside down. Now, if we do that on one side, just like we learned in the last unit, we have to do it on the other side as well. So this 6 over 5 is going to become 5 over 6. So now that it's written this way, it's pretty easy. We just got to get rid of this divide by 2. So to get rid of divide by 2, we multiply by 2 on both sides, and that's going to give us 10 divided by 6 equals x. So that's going to actually give us, because those canceled out, it's going to give us x is equal to 1.67. I'll round it off, but it continues forever. So now we know that that x right there was actually 1.67. These are the only really two types of questions you're going to get. Either x is on the top or x is on the bottom. You're always going to solve them the same way. So you need to get really good at being able to solve these and get all the way to the end, because every single question works like that. Now, the harder part of this unit and proportions is actually making your own. So you're going to get a situation where they're going to give you a shape. Let's draw a better rectangle than that. Okay, and then they give you a shape that's to scale, a similar shape, and let's say they gave you the numbers. So this will be 2 centimeters, 5 centimeters, this will be 10 centimeters, and this will be an unknown. So your job is you need to figure out what this number is using the rest of the numbers. So what we're going to do in these questions is set up a proportion. Now, I hope you're probably thinking, oh, this is pretty easy to figure out. The reason proportions work is when we have decimal questions, we can figure it out. So I'm going to set up a proportion. It is going to look like this. Every single time I do one of these questions, it's going to be like this. A fraction is equal to a fraction. You know you got to use these 4 numbers. You just got to put them in the right spots. So what we're going to do first is I'm going to pick which sides match with which. So I got a 2 and an x, and then I got a 5 and a 10. Now, the way I like to do it is I always like to write new divided by old on the side, so I can kind of see what's happening. So basically what we're going to do, this is the new shape, and this is the old shape, because it changed into this using the scale. I'm going to fill in the numbers. So on my new shape, I'm going to pick a side. It doesn't really matter. Let's pick this 10. Okay? I'm going to put the 10 right there. It's on top because it's a new shape. Now I have to put whichever number matches from the old shape. That's going to be the 5, because these two sides correspond with each other. They're the tops. So that's going to be 10 over 5. Now for the second one, I have to pick, again, another new side. So on the new shape, I'm going to pick this x, and I have to pick which number matches with it. Well, that's the 2 over there, so it goes right there. So now we can actually fill in the numbers and solve the question. Now, let's finish it, and I'll kind of explain where this comes from. So we're going to solve this just like we did the other one. I got to get rid of the 2, multiply by 2. So it's going to turn into 20 divided by 5 equals x. So it's going to be 4 equals x. So that means that that side length right there was actually 4 centimeters, and we solved it. So you might be wondering, well, Mr. K, where did this come from? Where did we get this original part of the question? So I want to explain. Basically, what we're doing is we're comparing the ratios. We're comparing the scale. So we talked about in the last video that the way you can find the scale is you can take the new side and divide it by the old side. So for example, in this question I'm doing right here, I know that the 5 and the 10 match. So if I took the 10 divided by 5, that's going to give me the scale, which is 2. The scale is 1 to 2. Now, if I did that scale using the ones we just talked about, so the scale is equal to 10 over 5. But if I took this 2 and this x, that should also equal the scale. If I took x divided by 2. So basically, this is the same as this. So if those two are equal to each other, I can just write them like this. Or the other way, because that's how I wrote it the first time. Sorry. 10 over 5 equals x over 2. Because the idea is that both of these, both this one and this one, give us the scale factor. And the scale factor is the same because it's a similar shape. That's the rules. So writing it this way is saying that these two things are equal to each other, which means that we can use that rule to figure out what x is. Now, if that's kind of confusing, it's okay. The important thing for you is being able to take a question like the rectangles we had here, and write a proportion. Let's do one more just to make sure you kind of see how to do it. So I'm going to take a triangle and make a littler triangle. Okay, let's call this like 8, 7, and 10 centimeters. And then on this one, let's call this 2 centimeters, x, and y. So the first step we had to do, actually think for yourself what you would do first. So I'm going to match up which sides match. So this one, those two go together. So I'm going to write new over old, and I'm going to write 2 over 10. Now I'm going to pick two new sides that match. You got the 8 and the y. Okay. So I'm going to write, again, we got the new shape is over here. This is new, this is old. I'm going to put y over 8. We also, instead of writing that, we could have written x over 7. We need to pick ones that only have one variable. So if you pick these, it's good. If you did these two, it wouldn't work because there's two letters. So we're going to do these two. Ignore this for now. So basically, we're going to isolate like we always did, times 8. And it's going to turn into y is equal to 16 over 10. Y is equal to 1.6. That's the basics of how you do it. We're going to do more practice, but that's the main idea.